Okay, in this lesson we're going to be writing polynomial functions. There's actually going to be two videos for this section, and this is what we're going to focus on first. I do want to mention that in section 4.3 we were only finding rational zeros. In this section you're going to see that we'll be finding also irrational and imaginary zeros, which are going to take a little more work. Anyway, let's go ahead and get started. It says here we have learned how to factor and find zeros of polynomial functions. In this lesson we will be completing this process in reverse. Write a polynomial having the given zeros. Assume multiplicity is 1 if not stated. You may leave your answer in factored form. So on the first one here it says x equals 4 is a zero of multiplicity 3. So if I write a function, well, I just want to remind you, we know that if x equals 4 is a zero, that x minus 4 would be a factor for the polynomial. In fact, we also know that the point 4 comma 0 would be an x-intercept. These are three things that we know together, three facts. So if we know a zero, we know a factor. So here we can say f of x equals x minus 4. Now I could write out three factors of x minus 4 since the multiplicity is 3, but normally we just put an exponent on there, so that would be cubed. And if x equals negative 6 is a zero, we know x plus 6 is a factor. Multiplicity is 5, so the exponent here is 5. So I just want to remind you, and we'll do this throughout this section, you should be able to find the degree of this polynomial. Well, when we're in factored form, what I had said is to add the exponents on all your algebraic factors. So in this case, 3 plus 5 tells us our degree is 8. So you may want to try number 2 on your own and then check my answer. All right, let's see how you did. So let's see. So first of all, let's go ahead and we need to write it as a polynomial, so we'll use fx. F of x equals, so we know if 0 is a 0, that x is a factor. We know that if negative 6 is a 0, that x plus 6 is a factor. And since the multiplicity is 2 there, we have two factors of x plus 6, which we write as x plus 6 squared. 7 is a 0, so x minus 7 is a factor. Multiplicity is 4, so that's to the 4th power. And finally 2 is going to be a 0 of multiplicity 1, so x minus 2 is the factor. And so we end up with x times the quantity x plus 6 squared times the quantity x minus 7 to the 4th power times x minus 2. All right, let's move on to number 3. It says write a polynomial having the given zeros. Assume multiplicity is 1 if not stated. Now here's what's different. It says multiply out the factors so that the polynomial is in general form. So the first step on these problems is going to be easy, but there's going to be a lot of tedious multiplications we've got to do, as you'll see very quickly here. All right, so on number 3 here we have zeros of negative 1, negative 2, and 5. So, oops, I forgot to put the degree in up on number 2. You just add those exponents there, you get 8. Okay, let's go back to 3 here. So f of x, there's another thing I wanted to talk about before we get into that. Notice it says write a polynomial. So before we go to number 3, I just want to mention this here. Right now on number 1, this is a coefficient of 1, but it really could be any coefficient, and so there's literally a limitless number of ways we could do this. The other thing is we've written a polynomial with that has these zeros as, I should say, it has these zeros for the polynomial, but we could also have other factors and other zeros. So this is like a minimum or the most basic polynomial that we could write. And so that's how we'll normally do things. So on number 3, now we can look at number 3. So first of all, we have the 3 zeros, -1, -2, and 5. And so our factors, we're going to be degree 3. Our factors are x plus 1, x plus 2, and x minus 5. So again, we could have a higher degree. We could put coefficients other than 1 here, but we're going to keep this simple. So you really could multiply these binomials in any order you want. I'm going to go ahead and multiply these guys here first, the first 2 binomials. So let's go ahead and distribute here. We'll get x squared plus 2x. Really, we're foiling. And then 1 times x and 1 times 2. And just rewrite the x minus 5. So 2x and an x, we can write that as x squared plus 3x plus 2. And so now we'll go ahead and distribute x times each of the 3 terms here. We get x cubed plus 3x squared plus 2x. And then we'll distribute the -5, so we'll get -5x squared minus 15x, and -5 times 2 is -10. So we do have some like terms to combine here. So we're going to get there's only one x cubed term, so we have x cubed. We've got a 3x squared and a minus 5x squared, so that's minus 2x squared. We've got a 2x and a minus 15x, that's minus 13x, and then the minus 10. All right, so this would be the most basic polynomial that we could write, having the lowest degree. So notice number 4 would also have a degree of 3. Now you might want to go ahead and see if you can write the first line based on what we've already discussed, and you could certainly try to multiply it out as well. All right, so you should have gotten x minus 1, or f of x equals x minus 1 times x minus 5i times x plus 5i. Now we definitely want to multiply these together first. It's not that we have to, but it certainly makes our work a lot easier. These are conjugates, and multiplying conjugates actually is quite easy. So let's go ahead and do that. We'll rewrite the x minus 1. X times x is x squared, and we don't need to do the outer and inner product here. They're just going to be opposites. And then we have -5i times a positive 5i. That's going to be a minus 25i squared. And so let's see, don't forget I squared is -1. So we're going to end up with x minus 1 times the quantity x squared plus 25. So now let's go ahead and FOIL this out. We'll distribute the x. We get x cubed plus 25x minus 1x squared minus 25. And the only thing left to do here is write this in descending order. You get x cubed minus x squared plus 25x minus 25. All right, let's move on to the next page here. Now number 5 is a lot like the one we just did, so again I'd really encourage you to go ahead and see if you could do that one and then check the video. So again, notice this is going to have a degree of 3, and your first step you should have said f of x equals x plus 2 times x minus the square root of 3 times x plus the square root of 3. And again, we're going to want to FOIL these conjugates first, or multiply the conjugates here. And so let me just rewrite the x plus 2. X times x is x squared. Square root of 3 times square root of 3. Well, I would remind you that when you multiply a square root times itself, you get the number inside. So here you're going to get 3. The reason why is because what we're really doing is squaring the square root of 3. Remember, squaring and taking a square root are opposites. And so if you do those back to back, you're going to get the 3 that you start with. So up above we have a negative times a positive. It'll be minus 3. And let's go ahead and FOIL this out. You'll get x cubed minus 3x plus 2x squared minus 6. And that's going to be it for that one. Just go ahead and write it out here. All right, now number 6 is going to be a little bit long. The reason why is because notice you have x equals negative 1 having a multiplicity of 3, and then you have zeros of 4 and 0. So let's, first of all, we're going to have a degree of 5 here. Notice if you count multiplicity, 3 plus 1 plus 1, that's going to give you 5. So let's go ahead and write out our factors. We got f of x equals, we're going to have 3 factors of x plus 1, which we'll write as x plus 1 cubed. And then that'll be times x minus 4 times x. Let me go ahead and change the order here. We can always do that with multiplication. We have x times the quantity x minus 4 times the quantity x plus 1 cubed. All right, so we can, again, multiply in whatever order we want. I want to go ahead and cube the x plus 1. And in fact, just to kind of keep things kind of clean here, I'm going to do that off to the side. So let's see, first I'm going to multiply 2x plus 1s. When you FOIL that out, you get x squared plus 2x plus 1. You can check my work, but that's what you do end up getting. And then we need to multiply by another x plus 1. So let's go ahead and distribute the x. We'll get x cubed plus 2x squared plus x. And then when we distribute the 1, we're going to get x squared plus 2x plus 1. And when we combine our like terms, we end up with x cubed plus 3x squared plus 3x plus 1. So I'm going to go ahead and replace x plus 1 quantity squared with what we just got. So again, we can really do this a couple of ways. I think I'm going to go ahead and multiply these guys out next. And so first of all, I need to distribute the x. I'll get x to the 4th plus 3x squared, or cubed, plus 3x squared, and then x times 1 is x. And then we'll distribute the negative 4. We'll get negative 4x cubed minus 12x squared minus 12x, and negative 4 times 1, we get minus 4. You'll notice we have some like terms we need to combine here, so let's take care of that next. So 3x cubed and a minus 4x cubed gives you a minus x cubed. You've got a 3x squared and a minus 12x squared, that's a minus 9x squared. You've got a 1x and a minus 12x, which is a minus 11x. And don't forget the minus 4. So finally, all we have to do is distribute the x. And we're going to get x to the 5th minus, well, f of x equals x to the 5th minus x to the 4th minus 9x cubed minus 11x squared minus 4x. All right, let's move on to the next page. It says important facts about polynomial functions. So it says if a plus bi is a 0 of some function f, so that would be a complex 0, then a minus bi is a 0 of f. Well, that would actually be the conjugate. In other words, complex zeros come in pairs, and like I said, they're conjugates. And the same's true with radical or irrational zeros. In 2 it says if you have a plus c square root of b, then you're also going to have a minus c square root of b as a 0. So these types of zeros also come in pairs, and again, they are conjugates. So if you look at number 7, before we do that, think about when we were doing or using the quadratic formula. There were a lot of times when we'd get an answer with a radical or an answer that was imaginary. And they always came in pairs because of that plus or minus. And so it makes sense that they would come in pairs. Let's now look at 7. It says, suppose that a polynomial having a degree of 6 has negative 2 plus 5i, negative 2i, and 1 plus the square root of 3 as zeros. What are the other zeros? Well, if negative 2 plus 5 is a 0, we know the conjugate, negative 2 minus 5i, will be a 0. Now, notice with negative 2i, that's really 0 minus 2i. We just don't normally write the 0, which means 0 plus 2i would be the conjugate, or just 2i. And then the last one here, you would get 1 minus the square root of 3. All right, let's look at 8. Suppose a polynomial of degree 4 has the given numbers as zeros. Find the other zeros. Well, we have negative square root of 2, negative 1, and 4/5. Well, we know that irrational numbers like square root of 2 come in pairs, and so x equals positive square root of 2 would be the other one. So just watch out when you're doing your homework. There may be some problems where they don't give you all the zeros, but if they give you a situation like 7 or 8, you're supposed to know that these types of zeros come in pairs, and if you're missing one of them, you got to make sure you include it. All right, so let's move on to number 9. This will be our last problem. It says, find a polynomial of lowest degree with rational coefficients that has x equals negative square root of 2 and x equals 3 plus I as two of its zeros. All right, so if x equals negative the square root of 2 is a 0, then we know the square root of 2 is also 0. And if 3 plus I is a 0, we know that 3 minus I is a 0. So I'm just going to warn you, the hardest part about this problem is doing the algebra. You may want to try it and then check your answer. And I'll just tell you, there's more than one way to do this. There's really two major ways that you can do it. So again, give it a try if you want, and then watch the video. All right, so you should have started out by writing your function in factored form. Now it does say of lowest degree, and so notice we have 4 zeros, so we want to write a basic polynomial with a 1 out front that has a degree of 4. So it'll be f of x equals this, x plus square root of 2 times x minus square root of 2 times x minus parentheses 3 plus I, and then x minus in parentheses 3 minus I. Now you could actually distribute those minuses on these last two here, but it actually is a little bit easier, I think, to leave it as it is and do it the way I'm going to be doing it here. Either way will work. All right, so the first thing I would want to do is go ahead and multiply my conjugates here. And so we get x times x is x squared. Again, we know with conjugates we could just multiply the first terms and the last terms. Square root of 2 times a minus square root of 2 is going to be minus 2. And now we'll do the same thing here. We're going to multiply this out. Now this one's going to be the harder one. We'll multiply x times x, we get x squared. Now there's no shortcuts here. These are not conjugates. We'll do x times a minus 3 minus I, so that is minus x times 3 minus I, the quantity 3 minus I. And then we're going to multiply, again we have a minus x times 3 plus I here, so very similar. And then notice our last product, a negative times a negative, we're going to get a positive 3 plus I times 3 minus I. So we have a lot of cleanup to do here to simplify this. So I'm just going to rewrite the x squared minus 2. We've got x squared. Minus x times 3 is a minus 3x, just distributing here. A minus x times a minus I is a plus xi. Minus x times 3 is 3x. Minus x times I is a minus xi. We're going to go ahead and distribute here. We got 3 times 3, that's 9. Again, these are conjugates, so I'm just going to multiply the first and the last products. I times a minus I is a minus I squared. Still got some cleanup to do. So again, I'll rewrite the x squared minus 2. Let's see, we've got x squared, a minus 3x and a minus 3x. That's a minus 6x. Notice xi and a minus xi, those cancel each other out. And then you have 9 minus negative 1. Well, I squared is, you have 9 minus I squared is negative 1. So this is really 9 plus 1, or 10. So finally, we can go ahead and multiply this binomial times a trinomial. Let's distribute the x squared. We get x to the 4th minus 6x cubed plus 10x squared. When we distribute the minus 2, we get minus 2x squared plus 12x, plus 12x, and then negative 2 times 10 is minus 20. So finally, let's see, actually we do have a couple of x squared terms we can simplify. So you end up with x to the 4th minus 6x cubed plus 8x squared plus 12x minus 20. All right, and so that's the end of this video. I'll do a second video for this section.